All right, for today's questions, 26 and 27, I'm going to change what we're going to call the amplitude and the period, okay? So notice, now I have something here. I'm going to use sine and cosine, but here my theta, I could be dividing or multiplying. That's going to change my period, I know. So yesterday we talked about the period of sine and cosine, and it says it repeats every 2 pi. So I'm gonna change how often does it repeat. It might take more than 2 pi to repeat, or it might take less, right? So I'm gonna divide, I'm gonna multiply. So that's actually gonna change our period. And then this number at the very front, you guys see a 4, you guys see a 3. That's gonna change our amplitude. How much does it open? From the parent functions, looking at sine, right, we had sine yesterday. Let me graph this line here in the center. It happens to be the x-axis on the parent function, but this sine, notice how from the centered, it goes, how far does it go up or down? So from the centered, it goes 1 up and 1 down from the centered. Technically, I had a 1 in front of my parent function. So it said it goes from the center, it goes up 1 and down 1. So looking at number 26, my amplitude is 4. So that means that from the center of the graph, it's going to go 4 up and 4 down. So that's going to be changing the amplitude. So let me just say the amplitude. So there's a couple things that I need to know. My amplitude is going to be 4. Exit the number at the very front. Now I need to find out the period. How long does it take to repeat? Now I have the theta over 3 is equal to 2 pi. Right, we talked yesterday that the parent function, the period is 2 pi, so it takes 2 pi to repeat. Now my theta is the new period. I want theta by itself, so theta divided by 3. If I ask you simple math operations, what do we do to get rid of the dividing by 3? You guys will say, well, let's multiply both sides by 3. So I get that theta is equal to 6 pi. Now, what does this mean? It takes 6 pi to repeat this function. Now, my period in this case is going to be 6 pi. Let me come back to the parent function. Let me highlight in blue one period. So for sine, starting here at 0, 0, it gets this figure right here. So it takes 2 pi to repeat. So notice how in the center it is 0. So 0, 2 pi, 0, pi, and 2 pi is where I'm going to have my zeros. So I'm going to say, all right, now here for my new graph, my 0 values are going to be 0, 6 pi. This time is going to be 6 pi because it takes 6 pi to repeat. And then I ask myself, man, I need the point in between 0 and 6. Well, the midpoint in this case happens to be 3 pi. So now, just to show you guys what I have in mind, something like this. So this is not the quite graph, but something like this, okay? So you guys see the graph of sine. So this is kind of like what I'm expecting, but I need to know how far up and how far down do I go. Now, in the middle, in between 0 and 3 pi, right in the middle, I'm going to reach the highest point. But didn't we say the amplitude now was 4? So in between 0 and 3 pi, I'm going to reach 4. So I'm going to say this is a point on the graph. In between 3 pi and 6 pi, right in between, I'm going to reach the lowest point, which we said was -4. Now I have a better view of my graph. So matter of fact, I'm going to say a 9 pi happens to be 0 again. And then right in between them, right in between 6 and 9, right in the center, I'm going to reach 4. The 4, remember, is the amplitude. Okay. Now let me use in red. My graph should look like this. Let me zoom out. You guys see how it looks like sine. The only thing is that I change how up and down it goes and how long does it take to repeat. And now let's play with cosine. Let me remind you guys of the parent function. This is how the parent function looks like. And let me take some information here. The amplitude. Let me write amp for amplitude. In this case, it's going to be 3. I got that from right here. The period. Now, how often does it repeat? So I know that 2 theta, I'm getting that from here. 2 theta is equal to 2 pi. Whatever I have in there, I always gonna let it equal to 2 pi because on the parent function, the period is 2 pi. I'm solving for theta because theta is the new period. Okay, so now to get theta by itself, let me divide by 2's. So I get that theta is equal to 1 pi. Okay, so I'm gonna have the image of cosine, but the amplitude is gonna go as high as 3 and as low as -3. And my whole graph is going to repeat in just, my new period is pi. Not 2 pi, but pi. Remember in the original, it took to repeat 2 pi, but now it's gonna repeat every 1 pi. So I'm gonna shrink it sideways and I'm gonna stretch it up and down. Okay. So let's take a look at important points. My beginning, it's a 1, or the amplitude, and right in the middle, it's the lowest point it can go. So in my case, in my new case, I'm gonna say at 0 is 3, because we said that our amplitude was 3. So at 0 is 3, and at pi, because remember the whole period now it's pi, is the highest point as well. Right in the center, so right in the middle between 0 and pi, it's going to reach the lowest point, which is pi over 2. It's going to reach -3. And I'm going to have between the highest and the lowest point, right in between is going to be 0. So here pi over 4 is going to be 0, and 3 pi over 4 is going to be 0 as well. Okay, so I have my important points there. Nope, that erased. It's right here. And I can even graph it again. I can put other points here. From pi to 2 pi is going to repeat again. Right in the middle, going to reach the lowest point. And it's going to be 0 here and 0 here. And then I can graph this. I'm graphing with my finger, so excuse the how if I'm off, like I said, I'm graphing with my finger, so. So there, it looks like the cosine is just that I stretched it up and down, right? I changed the amplitude, and it doesn't take 2 pi to repeat. In this case, it takes just 1 pi to repeat. I changed the period as well. But everything starts from the parent function. So if you guys are using sine or cosine, these are the parent functions. Okay.